Hello everyone. In this experiment, we are going to perform feature selection and feature extraction using Toyota dataset. And this experiment helps us improve unnecessary features, while feature extraction helps us reduce dimensionality and create meaningful features. So this is the main purpose of this experiment. So I have imported all the necessary libraries which are required for this feature extraction and feature selection. And as we proceed further, I'll be explaining you what are these terms and why we had used all these things according to the question. So as usual, the first one is to read the data. I have here used b3 Toyota feature.csv, and to check whether my data is loaded or not, I have used print statement, and I have printed the first five columns of it to make sure that my data is being read properly. So here's the output. So yeah, moving further, here the second question says drop BOBAG guarantee and doors columns. So here we remove the columns BOBAG guarantee and doors because they may not be useful for feature selection or modeling. The inference what we get is that removing irrelevant features reduces data set complexity. That is the inference we can get from here. Moving further, identify numerical columns with outliers using IQR, drop them and display their size. Okay, so we have the formula for IQR, which is there are two IQR formulas. The IQR is Q3 minus Q1, and the lower bound Q1 minus 1.5 into IQR, and the upper bound is Q3 plus 1.5 into IQR. Here, we detect the features that contains outliers using the interquartile range method. If any values lies outside the lower or upper, the column is considered to contain an outlier. That's the meaning and the feature which you get from here. These columns, I would say these columns, which is HP, automatic, guarantee period, and price. These columns, they give us the extreme values. That is why those columns are removed. The next question is identify numerical columns with variance less than 10, drop them, display their size. Alright, so here the concept of variance. Let's understand the concept of variance first. Variance measures how much value changes. If variance is very small, the feature will not contribute that much to the information. So here, as you can see, the low variance, less than 10, is manufacturing years, met color, automatic, and manufacturing guarantee. So what happens is, these are the columns which have very low variance, and that is the reason why they're removed, because their values are very little across the dataset. So low variance features does not help in machine learning models. So next question is identify the input columns with correlation less than 0.2% with target price. So in this question, let's understand the concept of correlation. So correlation measures relationship between variables. So it is in the range between -1 to +1. So if the correlation is less than 0.2 percentage, the output which has come here is kilometer, met color, automatic CC, quarterly tax, and so on. So these features have very low correlation with the target variable, that is price, and they are considered to be weak predictors because with this less correlated variables, they do not help in predicting something useful with the help of price, which means when the target variable is price, they are not something that contributes in predicting the price for future. That is the reason why these features do not influence price that much significantly. That is the inference which we get from this question. Drop the columns with 0.2 correlation and display their size. So here we remove the features that have correlation less than 0.2% with the target variable price. So after removing, the dataset size has become 50 rows and 6 columns. And next one is identify highly correlated feature pairs. When two features are strongly correlated, they contain similar information. For example, age or manufacturing month, like that. So here, this question tells us this particular piece of code will give us those kind of pairs which is highly correlated and which contains similar information. That's the main purpose of it. So when they contain similar information, we have found out that age, manufacturing month, CCN quarterly range, and CCN weight. These three pairs are highly correlated. Moving further for the next question, drop one feature from highly correlated feature based on its correlation with target feature price. So from here, from each highly correlated pair, we keep the feature that has high correlation with the target variable price and drop the others. So we found out that this particular piece of code gives us those features, the features which are supposed to be dropped, which is manufacturing month, CC and weight. These reduces the redundant information. So the inference what we get here is by dropping these three columns, we can reduce the redundant information. That's the inference we get from here. Now, separate the input features and target Y. So as usual, X stands for input features, Y stands for price. Here, we separate the dataset into input features and target variable. The target variable here is price, which we want to predict. That's it, nothing much. So the next question is univariate feature selection using select k best chi-square where k is equal to 2. So the concept of select k best selects the top k most important features. So the output which you got here is the top 10 features are age, manufacturing month, KM, HP, and so on. Here we use chi-square statistical test to identify the most relevant features. So the inference what we can get from here is these features have strong statistical relationship with the target variable. That is the inference we can get from here. The next question is mutual information score and highest feature. So here the concept of mutual information is that it measures how much information one variable gives to the other variable. And high mutual information which we get from the output here is manufacturing one. That is the most that's the feature that provides the most information about the price according to the mutual information score. The next question is feature extraction using PCA. PCA stands for Principal Component Analysis. The purpose here is to reduce the dimensionality. So the steps which we involve here is standardize the data and then compute the covariance matrix, find the eigenvalues and eigenvectors, project that data into principal components, and that's how it works. So here, the PCA, the principal component analysis, convert the original feature into components that capture the maximum variance in the data. So here, um, we have two outputs. The two principal components are generated. From here, what the inference you can get, the data set dimensionality is reduced. That's the main purpose of PCA. So the next one is feature extraction using LDA scalar. So here we are using linear discriminant analysis. So the purpose here is also to reduce the dimensions while preserving the class separation. So LDA reduces the data set into two components while maximizing the class separability. That's the concept here. And we found out the result is 50 rows and 2 columns. Next, the last question is read an image lena.png, extract the pixel by pixel mean feature and display. Here, what we do is we extract the RGB values, compute the pixel mean, red plus green plus blue, we take the average of that, and then we perform image feature extraction by calculating the mean pixel intensity for every pixel. The output has two images. One is the original image, the second one is the mean feature grayscale image. This helps in converting the image into a grayscale image. This is the code and this is the output. You can see I have taken the mean and then found out these are the two original. So this is the experiment where we performed feature selection and feature extraction techniques such as variance filtering, correlation analysis, select K best, mutual information, PCLDA. These methods helps to reduce the dimensionality and improve machine learning models performance by selecting only the most relevant features. Thank you.